Hello everyone, you're welcome back again. We're going to solve for the value of p from this cubic equation. We call this cubic equation because the highest power of the variable here is 3. And in this equation, our interest is to find only real solution that will satisfy this equation. Now, we're going to start by solution. So the first thing we're going to do is to take this positive 10 to the left hand side. So we're going to have p raised to the power of 3 plus p. Then when this 10 cross to the right to the left hand side become negative 10, which is going to be equal to 0 because there's nothing left in the right hand side. So the next thing we're going to do, if you look at this term 1 2 3, so this is just 3 terms, so we want to make it to be 4 terms so that we can group into two terms, so that we are going to have p raised to the power of 3. Then this p can also be written as what? Minus 4 plus 5p. If we write minus 4p plus 5p, it's going to give us positive 1p. So we just transform this p as what? Negative 4p plus 5p. So then this minus 10, which is going to be equal to 0. Now we're going to group this into two terms. So the first two terms is what? P to power 3 minus 4p, then we group it, then plus the last two terms is 5p minus 10, then we group it also, which is going to be equal to 0. Now we're going to factor out the one that is common. Now if you check here, p to power 3 then 4p, that means p is common, so we factor out the one that have least power, which is just ordinary p. So we're going to factor out p, then we open bracket. P to power 3 divided by p is going to remain p to the power of 2. Then minus 4p divided by p will cancel, it will remain only minus 4. Then plus, here what is common? 5p minus 10. Here there's no variable, but 5 can go into 5 and also it can go into 10. So therefore 5 is common. So we factor out 5. 5p divided by 5 is going to remain p. Then minus 10 divided by 5 it will remain minus 2. So everything will be equal to 0. So the next thing we're going to do, if you look at this first bracket, p to power 2 minus 4, so we can change it to difference of 2 square, so that we have p, now open bracket, p to the power of 2 minus 4 in index form to the base of 2, so that we can have difference of 2 square is going to be what? 2 raised to the power of 2. This is the same as 4. Then plus 5 into p minus 2, which is going to be equal to 0. Now from here we are going to recall that when we have a raised to the power of 2 minus b raised to the power of 2, this is the same as what? A plus b then multiplied by a minus b. So this is the simplification of difference of 2 square. We are going to apply this property to this bracket so that we have what? P square minus 2 square can be simplified as the right hand side here, so that we have p, which is this initial p outside the bracket, then we open a mother bracket. P square minus 2 square in this form is going to be what? P plus 2 then multiply by p minus 2, then we close the mother bracket. So this is only this, then plus 5 into p minus 2, everything will be equal to 0. Now remember that this expression in the left hand side is in two parts. This is the first part and this is the second part. So what do you notice? Do we have anything in common? Yes. The first part we have p minus 2 in common, p minus 2 in this bracket, and also p minus 2 in the second part. So p minus 2 is common. Therefore, we're going to factor out p minus 2. Now we're going to open another bracket and do the cancellation. Now this p minus 2 is outside already, so it will cancel this. We are left with just p into p plus 2, then plus here p minus 2 will cancel this p minus 2 outside, it will remain only 5, which is going to be equal to 0. Now we need to simplify this inside second bracket. Inside this mother bracket we need to simplify. So here we are going to have p minus 2 close bracket, then into this bracket, p multiplied by p is going to give us p square, then p multiplied by 2 is going to give us 2p, then plus 5, everything will be equal to 0. Now recall that when two terms multiply itself to be 0, it's either the first one is 0 or the second term is 0. but we don't know which one is 0. So we're going to equate the first one to be 0, or p squared plus 2p plus 5 to be equal to 0. Now, if you take this negative 2 to the right hand side, it becomes positive 2. So p now will be equal to 2. So here we have quadratic equation. If you solve this quadratic equation, remember initially our interest is to find only the real solution. As you can see, recall quadratic formula which have this following unknown: a, b, and c, where a is the leading coefficient, which is coefficient of p squared, which is 1, b is the coefficient of the middle term, which is 2, and c is the c is the constant, which is 5. So this is the value of our a, b, c from this quadratic equation. If you substitute this into the quadratic formula, you are going to see that since this c is bigger than b, you are going to arrive at what we call a complex solution, because they are going to introduce what we call an imaginary number. So therefore, if you solve this quadratic equation, you are going to arrive at no real solution. So no real solution except what we call a complex solution. So therefore, the only solution that will satisfy this equation is p is equal to 2. And for us to check that truly that p is equal to 2, we are going to substitute anywhere we see p as 2 to the original equation, which is what? P to power 3 plus p equal to 10. So we need to copy the original equation. We are going to check now. So the original equation is what? P raised to the power of 3 plus p, which is equal to 10. Now anywhere we see p, now we're going to replace 2. So this is going to be what? 2 raised to the power of 3 plus, in place of p, is going to be 2. 2 to the power of 3 is going to give us 8. Then 8 plus 2 is going to give us 10. So therefore, the left hand side is the same as right hand side at p is equal to 2. So thank you for watching, and please don't forget to subscribe to my YouTube channel for more videos like this.